Hi, this is Bradley Bush, and we're back again to talk about another topic in algebra. We'll talk about the real number line, and then we will talk about inequalities. So this should be a pretty quick video. The real number line, if you look at my video on the real numbers, I'm discussing those real numbers when I talked about the real number line. So if we let x be a real number, and then this number line here, this horizontal line represents all of the real numbers. And if we put 0 right here in the middle, then we'll have 1, 2, 3, 4, and so on. And to the left, we'll have -1, -2, -3, and apparently I can't write -4, and so on. So 0's in the middle, positive numbers are on the right, negative numbers are on the left. The further you go left, the more negative the number is, or the smaller the number, and the further you go right, the larger the number is. So this kind of lends to an ordering of the real numbers. So we can order the real numbers. A number, and we can call that number n, is less than another number. We'll call that number m, if n, the first number, is to the left of the second number m on the real number line. And we have a way to write this ordering to express this relationship between these two numbers. And this is how we write it: n less than m. And the less than is this little carrot looking thing that's on its side. So that brings us to inequalities. We can say that n, some number that's a real number, is less than m, some other real number, if an expression, or that is an expression of an inequality. Saying this is an expression of an inequality. Apparently I can't even read my own writing. This means two things are not equal because one is less than the other. They're not the same. That's, in essence what inequality means. They're not the same. So this means these two things are not equal. And we have more than one of these symbols that represent inequality. And here's a list. So the first one means less than, and it is written like this. Let's come up with an example here. We're going to be coming up with these on the fly. So we'll say 4 is less than 7. So you would read that 4 is less than 7. The next one, number 2, is less than or equal to. And we know that it's less than or equal to because we kind of have this hybrid less than sign and an equal sign. It's kind of like you took a less than sign and an equal sign and you kind of smushed them together so that you had part of each of them. So because we have that little equal sign on the bottom, the meaning for this one is less than or equal to. It can be either of them, less than or equal, and it still is a mathematically valid statement. So let's come up with an example here. If we said 3 is less than or equal to 3, is that true? Well, technically it is. It's not less than, 3 is not less than 3, but 3 is equal to 3. So we can have either or, less than or equal. So 3 is less than or equal to 3, and we would read it or write it like that. The third inequality symbol is greater than. And we write it like this. Let's say -4 is greater than -8, because -8 is a smaller number. It's further to the left on the number line. So we would say -4 is greater than -8. And our final one is greater than or equal to. And again, we can see that it's greater than or equal because we have the little equal part underneath, the little horizontal line that kind of looks like half of an equal sign. So this is greater than or equal to, and let's come up with an example for this one. Let's say we already did an example in number 2 where we said we used the equal parts. Let's just do strictly greater than. Let's say 5 is greater than or equal to 2, which is true. It's not equal to 2. 5 is not equal to 2, but 5 is greater than 2. So because one of those situations is true, the whole thing is true. So we can say 5 is greater than or equal to 2, and we're done. So inequalities can express relationships between numbers on the real number line right here. And the further you move left, the smaller the number. And the further you move right, the bigger the number. And inequalities help us express those relationships. If you have questions about this, you can write it in the comments below. If you have questions about other topics in algebra or calculus, you can check out my YouTube channel and my algebra and calculus playlist. Thanks.